All right, we're live. Welcome to Bit Block Boom. Let's learn some Python together. Let's go to CodeWars, and we're basically going to start with challenges that I haven't seen before. So let's do kata. I have not trained on before. We're going to stick with Python. Let's sort by popularity. We'll stick with easy ones. Let's do 8 to warm up. 8's the easiest, and it gets as hard as 1. So let's see what we can do here. Okay, hopefully you can read this code here, or the instructions. Writing code to control your town's traffic lights. You need a function to handle each change from green to yellow to red and then to green again. Complete the function that takes a string as an argument representing the current state of the light and returns a string representing the state the light should change to. For example, when the input is green, output should be yellow. Okay, so from what I understand, the function will take in a string as an argument, and it's going to be one of three different options, right? Green, yellow, red. The first thing that comes to mind, we could just do some pretty basic if else statements. Right? Like if current is green, return yellow. So that comes to mind initially. Let's see what else we can do here. We could also plug in these. Let's just take it to Visual Studio. Just put in our test case right here. So like what I was thinking is we could do like a list, like light list, and then just type in like all these strings, right? Like but like what I don't think this would work because when we get to the end, say we get a green, I was just thinking kind of like rotating the slices. I don't think that works because we got to go back to green. That's the issue. I'm not really sure how to solve that. So like if current equals green, then oops, we need a semicolon. And we want to return yellow, right? And then like now if current equals yellow, we would like to return red, and then I guess the last edge case here would be like oh, it did. Okay, got it. So yellow. All right. And let's just try let's just try this one too. Comment that out. Green. Okay, I think this is correct code. Let's just plug this in here and see what happens. Yeah, it looks like it's right. All right, so I mean that was pretty easy. I wonder how else you could solve this. I mean, if we click the submit button, we'll be able to tell, but I bet you could do like a map, right? Like some type of map, excuse me, or even like a dictionary, right? Like, ooh, let me see here. So like if we had some like light dict, and we were kind of like so green, and then this one would be yellow. So we could do something like this. Yellow. This would be red, and then red would next be green, right? And then so we could return, and then so the key, so this would be the key that we want to return the value. Whoops. No, we actually want we want light dict, right? Because then green's gonna turn yellow. So I think this would work. Yeah. So this would work. So this should return yellow, just like the one above it. Yeah. So I think I like this solution better, right? Now I bet you there's a way to do this in one line as well. So like, let's just make sure that this is gonna test out. Yeah. So that works. So if we do this, we could try to make this one line. How would I do this? So like, need the dictionary here. Okay, we don't even need to assign that a variable, right? We could just be like, so that's the dictionary, and then would this work like that? Does that work? Yeah, I think it does, huh? Yeah, that's okay. So I don't know if this is best practice, but I mean, it's a one-liner. Not that that means it's better, but it's pretty easy to understand. You got a small dictionary, and then this is the key that for the value that we want to return, I guess is how you say it. I don't know. Let's just see what happens. Logic drills. Yeah, so okay, here's the dictionary for the first one. I don't know if it's clever. How does it work? Please explain. Yeah. That's the thing with these comments. Like everyone's like, oh, what about this edge case? But it's not included in the instruction. So it's like, don't worry about it. Okay, I guess that works. I don't know, is that clever? And then here's what we did, right? Yeah, we did the same thing. So cool. And then this is like our first iteration. Oh, they put an edge case here. This is not a traffic light color. Yeah, to catch like anything that's not one of these three colors. All right, cool. Oh, this is kind of what I was thinking in the beginning, right? With that list, I just couldn't figure out how to get back from red to green in the beginning. So color, and then they're doing an index. That's a little complicated. I'm not a big fan of this one. This one's kind of crazy. Oh, this is cool. It's not even a function. Okay. All right. Let's do another one. All right, sort by popularity. I only know how to do Python. Learning, so let's work on this. Approve. No, we just want approved ones. Progress. Things I have not trained on. Let's do that. Let's do the easiest one. We got to work our way up here. Don't worry about tags. Okay, so let's try this one. Get planet name by ID. So the function's not returning the correct values. Can you figure out why? So the ID is 3. It should return Earth. Return name. I'm not even sure what syntax. This is just, this looks weird. Oh, is that why it's like, I don't know what's going on here. Yeah, that's why this is like written very odd. Switch ID. I don't even understand what's going on here. I feel like 0. They just want a dictionary, so why? This would be very similar to the problem we just did, right? Like, you figure out why. 3, put Earth, debugging. I don't know. I think they're just like trying to say, hey, like, oh boy. Okay, so like, and then this would be the dictionary, right? It'd be like 1. Maybe it's faster if I copied and paste this like that. 2. Sorry guys, let me just go through this. Might take a quick second. Luckily, there's not too many of them, right? And the last one is Neptune. Okay. I think that's it, right? This was like literally the same one we just did. That's so bizarre that it was like right after each other. All right, let's just submit this one. Yeah, so they did the same thing. They put a dictionary here. Then they use this I guess it's called a method. They use this method get ID, and if it's not one of these numbers 1 through 8, this is I believe an optional parameter. It's like the default what it should return, and it would be none. I can show you that real quick. I don't know what's going on with the syntax here. Oh, I did copy the D. Okay, good. All right, so this should return Venus. Right, now let's just say I return 9. It should say none. None. Yeah, maybe if you print it, it returns none. Okay. Cool. All right. Well, that was like, I don't know, really fun. Okay, let's just forget about that. Okay. Count odd numbers shown below n. All right. So given a number n, return the number of positive odd numbers below n. Given n, return the number of positive odd numbers below n. Okay, looks like it wants us to return. Oh, okay, so it's showing a list here, but it actually wants just like a count. We're just gonna basically do a simple len return of this list. All right, so let's get here. All right, and then let's just try this one right here. So we'll copy everything. Like, hey, it is return 7. Because odd numbers below 7. Okay, so like I'll do this 2 ways. Let's just start with the basic way with like a loop. Our num in range, and it starts at 0, and it's going to be exclusive, so it's not going to include. So we need to do n plus 1, right? So if we enter 15, it would be 0 to 15, but 0 is not going to be odd, so we could literally actually just start at 1, save it sometime, and okay, so interesting here. So you got to pay attention. Given a number n, return the number of positive odd numbers below n. So it actually does not want us to include n, right? So actually, we just need n here. So let's just show like, see how this counts. That's what we want, and then we're gonna write some basic logic here. Let's just create a list, initialize like a list odd nums, and then I'm just gonna put that, make it a list, and then we're gonna basically say like if num divided by 2 modulo 2 equals 1, right? If this is 1, and we want to add it to append it to that and put that in there. and then basically just do return len. Oops. Yeah, okay, so this is like the first way to do it, right? So what we're doing here is we're looping through the range that from the argument that this function's accepting, and then we're just running a conditional if the first variable in this range, which is 1, if 1 modulo 2 is equal to 1, append it. I believe it is. We can actually just print out this list too, just so you can see it. So we can just do return, put it here. Odd nums. Yeah, so it's like, so 1 is an odd number, 3 is an odd number, 5, 7, 9, 11. So this would be the first way to do this. So let's just put it in there. We'll test it, but we actually want to, and it passed. You can see here it passed. So let's just do it again. But let me, let's try to do like a list comprehension here, or we could actually do a generator comprehension since I don't think we have to store this in memory. How would we do this? So we would basically, so like they teach you to like start with this, right? So it's like, okay, well, we know we want len, so it's gonna be len here, and then here's our generator expression, and then we want like x for, let's just do num for num in range, and our range is just 1 to n. Oops, 1 to n. If num, and we only want to include it like if num modulo 2 is equal to 1. Oh, whoa. It's oh, oof. Okay, all right, you know what? I guess we can't do an expression generator or generator expression. We got to do, yeah, so okay, it was forcing us, like basically we had to do a list comprehension. So what we're doing here is like num for num in range 1. So this generates the 1, 2, 3, 4, 5, 6, 7, all the way to 15. But we're saying only add these to this list we're creating if it's odd. And this is the if the odd part right here. If num modulo 2 is equal to 1. And then we're making that list, and then we're taking the length. We're just saying, hey, how many numbers are in here? What's the count? Like what's the length, I guess? And we're returning that. So that should be good. Yeah. Huh. Taking forever. What's going on? Oh, you know what? I wonder. Oh, they probably have like a huge number. Oh, wow. It timed out. Oh, in rare cases, the server may be taking on too much work and simply wasn't able to return your code efficiently enough. Most of this time, though, is caused by an inefficient algorithm. So if you see this error multiple times, you should try to optimize your code further. So look, they tested this big number right here, and they just said it wasn't efficient. Let's just try it one more time and see what happens. But maybe we can try to optimize this code. Maybe this code's too slow for like a big number. Looks like it is. It's taking a while. So let's just try putting in this one again. Oops, I gotta comment that. Let's just see. Okay, so past that, and then will it pass? Okay, we got an issue here. It's testing really big numbers, so this code's not efficient. Okay. Okay, so let's think of how we can. Maybe we can just break this apart here. I'm trying. I don't know. Like, I'm not very advanced here. I'm not sure. Maybe range isn't efficient, or maybe it's the fact that we're trying to check this conditional for each one of those numbers. Well, let's see if we can do that. And return odd. It's a generator object, and so what it told me earlier is you can't do that. Yeah, okay. Count. So count would only count the numbers. I think it wouldn't be faster doing this, right? This would be the same thing. It's hard. I don't know what's like happening behind the scenes here. I'm not really sure. If num modulo 2. Okay, let's maybe like look at performance algorithms, expect large inputs. Okay, so it's explicitly like testing us on like an efficient algorithm. That's what's happening here. Instead of tricking with us, they're like, oh, this is easy, right? But then expect large inputs. So let's see the discussion. Let's just see if we can get some hints here. Only think before coding. Okay, so we just got to use some basic math to optimize this. Oh boy, this is going to be scary. So something tells me that there's like something with like the big O notation. We got to figure out like a more efficient way to run this. All right, let's take a second here.